So we are going to solve question number 3. And in the following pages, we are going to solve a few more questions related to joint and marginal probability density functions of continuous random variables. So this is just our first question. For a randomly selected freshman student, so what is a freshman student? It means a first-year student. In a college, it's a first-year student. Let X and Y be the fractions of class participation in Physics 181 and Physics 184 classes. These codes are the codes in multiple university, my friends. So you can imagine the same question for your own university in Özyeğin. Okay, so this is your first physics class, and this is the second physics class, which you take in the first semester and the second semester. Now we are randomly selecting a student, and X and Y are representing the class participation fractions. So class participation percentages are simply percentages, and fraction means it's a value between 0 and 1. It is actually representing the ratio of participation. If the student participates in 100% of the classes, then the fraction of participation is going to be 1. If, for example, the student is participating in half of the classes, then the fraction participation is going to be 0.5. Therefore, for both classes, the class participation fractions are taking values between 0 and 1. Okay, so both of these random variables are taking values between 0 and 1. Now, what do you expect? Because X and Y, these are the class participation fractions to these both classes of the same student. So we randomly select a student, but X and Y, they belong to the same student. The student is random. So because the student is random, it is impossible to know about these class participations before we select the student, right? So therefore, these class participation fractions are random. However, of course, they should be dependent, right? Dependent on each other. For example, if a student does not participate in Physics 1 class, then most probably we do not expect the same student have a large class participation fraction in the second class as well. I mean, if a student is lazy, then that student is lazy in all of the classes almost. So there may be some exceptions. But usually this is what we observe in the university, right? And if a student is actually participating in any of the classes with a large percentage, then this means this is a common property of that student, and that student can also participate with a large participation fraction in all of the classes, not just one of them. So therefore, we expect X and Y to be dependent on each other. Because of that reason, it is a good idea, instead of modeling X and Y independently, it is a good idea to develop a joint probability distribution for X and Y, because they are going to be dependent. And that joint probability density function is defined as Cxy.